Welcome students in this session of a previous year questions paper of the class 12th physics, and the topic is ray optics. So let's begin with the first question. The first question we have: a convex lens of a glass mu g is equals to 1.45 has a focal length FA in air. The lens is immersed in a liquid of refractive index mu d is equals to 1.3. The ratio of F liquid by F air is, so we have an options 3.9, 0.23, 0.43, 0.39. Let's move with the solution part. So here we are using lens maker formula, which is a 1 by F is equals to mu2 minus 1 by R1 plus 1 by R. For more elaboration, I just want to do solution here. So the value of 1 by F is equals to the first light rays moving from the glass to air. So mu g by mu a minus 1 by R1 plus 1 by R. This is a glass to air contact. In the second scenario, the light rays passes from the glass to the liquid. So for that scenario, 1 by F is equals to glass to liquid. That comes mu G by mu L minus 1 by R1 plus 1 by R. We just take the ratio of these both two. So F liquid by F air, this value comes mu G by mu A minus 1 divided by mu G minus mu L. This will be L over here, minus 1. So the value of a mu G is given 1.45. Mu A is a 1. We know that already. The value of a mu G again 1.45 divided by the value of a mu L is 1.3 minus 1. So the value comes 0.45 divided by 0.11. That after solving, this value becomes 3.9. So according to this, the first option is the right answer. I hope you understand. Next question we have: three thin lenses are combined by placing them in contact with each other to get more magnification in an optical instrument. Each lens has a focal length of 3 cm. If the least distance of distinct vision is taken as 25 cm, the total magnification of the lens combination in the normal adjustment is, we have an option 9, 26, 300, 3. Let's move with the solution part. So here we are again using the lens maker formula, which is a 1 by F is equals to mu2 minus 1 by R1 plus 1 by R. For the case of a liquid and the case of air, and then take ratio and get the result 26. I hope this will be the easy for you students. Next question we have: an image is formed at a distance of 100 cm from the glass surface when the light from the point source in air field on the spherical glass surface with the refractive index 1.5. The distance of the light source from the glass surface is 100 cm. The radius of a curvature is, we have an options 20 cm, 40 cm, 30 cm and 40 cm. So these two options repeated, so I am just taken as a 80 cm. Now let's move with the solution part. So here I am applying lens maker formula, which is a mu2 by V minus mu1 by V is equals to mu2 minus mu1 by R. The mu2 is refractive index of the second medium. Mu2 is refractive index of the first medium. R is the radius of a curvature over here. So applying these particular terms and get the result 20 centimeter. For a more elaboration, I'll just want to do the solution part. Mu2 is given over here 1.5. So 1.5 by V. The image is formed at a distance of 100 minus mu1. This will be, we are taking as a glass, so air. So in the case of air, mu1, we know that this will be 1 and the value of a U is given. That glass surface is located at the 100 centimeters. So this is a given 100. Again 1.5 minus 1 divided by the radius of a curvature we have to work. Like this question we have to ask. So little bit solution there is a need and we get the result 20 centimeter. Moving ahead with the next question. A convex lens has its radii of a curvature equal. The focal length of the lens is a small f. If it is divided vertically into two identical plano-convex lenses by cutting it, then the focal length of the plano-convex lens is mu is equals to refractive index of the material of the lens. Option is given here, f by 2, 2f, mu minus 1 times f, and the fourth one is f. Let's move with the solution part. We are applied over here, 1 by f is equals to mu minus 1, 2 by r. And again, that 1 by f is equals to mu minus 1, 1 by r. If we divide the first to second, we get the result f prime is equals to 2f. According to this, the correct option we have, which is option 2. Next question we have, a thin converging lens of focal length f is equals to 25 centimeter forms the image of an object on screen placed at the distance of 75 centimeter from the lens. The screen is moved closer to that particular lens by the distance 25 centimeter. The distance through which the object has shifted so that the image on the screen is sharp again. Option is given 16.25 centimeter, 12.5 centimeter, 13.5 centimeter, and the fourth is 37.5 centimeter. So now, let's move with the solution part. Case 1, which we have 1 by f is equals to 1 by v minus 1 by u. What is f over here? Focal length. V, image distance or distance of an image from origin, or we have taken as an optical center also. U is distance between object from optical center. Now I'm just putting all these values over here. We know the value of a u is we have to ask. So I'm just assuming this is a x. After solution, we get the result of a x. X is equals to minus 37.5 centimeter. In a case 2, the focal length is same, but the thing is that the place of the position of the image is changed. According to that, the position of the object is also changed. In this scenario, the value of x prime we have taken as an object. So in the second case, x prime isn't taken as an object. In the first scenario, we have taken x is an object. After putting all these values, the value of x is given like minus 15 centimeter. So the difference of x with the x prime is 12.5 centimeter. According to this, the correct answer of this question is second one. I hope you understand, students. Moving with the next question. The two surfaces of a concave lens made of a glass of a refractive index 1.5 have the same radii of a curvature r. It is now immersed in a medium of a refractive index 1.75. Then lens. Options are become a convergent lens of focal length 3.5 r, becomes a convergent lens of focal length 3 r, changes as a divergent lens of focal length 3.5 r, changes at the divergent lens of focal length 3 r. Let us move with the solution part. So here I am applying the lens maker formula, which is a 1 by f is equals to mu minus 1 by r plus 1 by r, which gives the value of 1 by 2. So minus r by f is equals to 1.5, which is the value is given for the refractive index of a glass. And the second medium of a refractive index is given as a liquid material. So for that case, refractive index is 1.75. So the ratio of a mu, because we know that mu is equals to mu 2 by mu 1. Mu 2 by mu 1. So the second medium we have 1.5 and the first one is a 1.75. So 1.5 by 1.75 minus 1. And after a little bit solution, we get the value of f is equals to 3.5 r. So from here you can see the focal length comes positive. And when the focal length comes positive, the lens becomes converging lens or a convergent. And the focal length is came 3.5. So according to that, we have in first option is in right answer. Next question we have, a microscope consists of an objective of focal length 1.9 cm and eyepieces of a focal length 5 cm. The two lenses are kept at a distance of 10.5 cm. If the image is to be formed at the least distance of distinct vision, the distance at which the objective is to be placed before the objective is. Here we have a given one hint, that is the least distance of a distinct vision is 25 cm is given over here. Options we have 6.2 cm, 2.7 cm, 21 cm, 4.17 cm. Now let's move with the solution part. We are using simply lens formula. So lens formula is 1 by f is equals to 1 by v minus 1 by u. The value of f is given 5. V is given 25 and u we have to calculate. After the solution, we get the value of u, which is comes 2.7 centimeter. Here you have to take a little bit LCM, that is a short part of that particular calculation. So after solving, we get the option 2, which is the right answer. Next question we have, fractional diffraction is produced due to light rays. Students, we have in diffraction pattern, we have two types of a diffraction. I think you know about that Fresnel and Fraunhofer diffraction pattern. So both the diffraction pattern tells actually the how light rays is behaving as a particle nature. So Fresnel diffraction is produced due to the light falling to the small obstacle, and the intensity of the light at a particular point on a screen is beyond the obstacle depends on. We have an options the focal length of the lens used for observation, the number of a half period zone that superpose at that particular point, the square of the sum of the number of a half period zone, the thickness of the obstacle. Students, let's begin with the solution part, like how to solve. So conceptual solution we have this, the dependency is totally upon the number of a half period zone that superimpose at that particular point. So according to that, the second option is the right answer. Next question we have, the objective and eyepieces of an astronomical telescope are double convex lens with their refractive index 1.5. When the telescope is adjusted to infinity, the separation between the two lenses is 16 centimeter. If the space between the lenses is now filled with water and again telescope is adjusted for the infinity, then present separation between the lens is 8 centimeter, 16 centimeter, 24 centimeter and 32 centimeter. Now move with the solution part. With respect to the objective, G mu W. So that means glass to water. This is the representation whenever we are taking the relative terms with the refractive index, which is N2 by N1. So N2 is given 16 and N1 we have to calculate. Again, if we do change, so 9 by 8 is equals to 16 by x. From here we get the value of the x, which is 8 into 16 by 9. With respect to the eyepiece, G mu W is equals to x by 16. That means 9 by 8 is equals to x by 16. The value of x comes 18 centimeter. Present distance between the lens is L is equals to x plus x prime, which is 32.22 centimeter. According to that, the correct option, we have fourth option. Next question we have, the dispersive power of the material of two lenses forming an achromatic combination of the ratio 4:3. Effective focal length of the two lenses is plus 60 centimeter. So here the focal length is given, as you can see student, then plus 60. That means this will be converging. The nature of the lens is converging. Focal length of the lens should be, so we have an option minus 20 centimeter with 25 centimeter, 20 centimeter with minus 25 centimeter, minus 15 centimeter with 20 centimeter, and 15 centimeter with minus 20 centimeter. We have a solution. Omega 1 is equals to minus F2 by F1. Omega 1 is given 4 and omega 2 is given 3. So 4 by 3 is equals to minus F2 by F1. F2 comes minus 4 times F1 by 3, and F1 F2 by F1 plus F2 is given 60 centimeter. We just put the value of F2 and get the value of F1. So F1 comes 15 centimeter and F2 comes 20 centimeter. According to that, we have an option 4th, which is the right answer. Students, during the calculation, you must know, you must put this units. Unit have very important role during the exams. Next question we have, the focal length of the lens of the dispersive power is 0.45, which should be placed in the contact with a convex lens of focal length 84 centimeter and the dispersive power 0.21 to make an achromatic combination from the two lenses is in centimeter is 45 centimeter, 90 centimeter, 180 or a minus 180. Now move with the solution part. The condition for achromatic combination, omega 1 by F1 plus omega t by F2 is equals to 0. Now for the NEET and for the JEE examination, this is a very important formula, as well as for the board students also. So where omega 1 and omega 2 are the dispersive power of the lens F1 and F2 are their focal length 0.545 divided by F1 plus 0.21 divided by 84. This comes the value of F1, which is a minus 180 centimeter. According to this, the option is the right 4th. Next we have, which of the following statement are true in the context of a compound microscope? So student, we are generally taking a mean of compound microscope as a microscope which is only single lens have, which we are saying as a binocular also. So the option which we have, each lens produces a virtual and inverted image. The objective has very short focal length. The eyepiece is used as a simple magnifying glass. The objective and eyepiece are the convex and concave lenses respectively. So we have an options of 4A and A, B and D, B and C, A, C and D, and B and D. So let's move with the solution part. In a compound microscope, we know focal length of the objective will be less than the focal length of the eyepiece. And second, eyepiece is used for simple magnifying glass also. According to this, the correct option we have a second one. Next question, we have a ray of light refract from the medium 1 into a thin layer of a medium 2, crosses the air and is incident at the critical angle on the interface between the medium 2 and 3, as shown in the figure. If the angle of incidence of the ray is theta, the value of a theta is. So this is a given diagram. Theta we have to calculate it. Okay, the mu1 is a given, mu2 is a given, and mu3 is a given. So according to this value of a mu, we can conclude the first medium is a rare medium with respect to the second medium, and second medium is a rare medium with respect to the third medium. So if we are taking the medium second and third, the second one is rare, and if we are taking the value first and third, the first one is a rare medium. Again, I am repeating, students, the first medium, as you can see, they have a very less refractive index. So this will be, I am taking as a rare medium. Second, very high refractive index this will be, so this will be denser medium. Again, this will be a rare medium. Option sine inverse 8 by 9. Second, sine inverse minus 13 by 18. Third, sine inverse 13 by 16. And fourth, sine inverse 8 by 13. Now move with the solution part. From the figure, mu2 by mu1 is equals to sin I by sin r. We just put all these values. 1.9 divided by 1.6 is equals to sin I by sin r. In the interference of second and third medium, mu2 by mu1 is equals to 1 by sin c, where c is the critical angle. So 1.8 by 1 by 1.3 is equals to 1 by sin c is equals to 1 by r. So sin r is equals to 1.3 divided by 1.8. From equation 1 and 2, we can say that sin theta is equals to 1.6 by 1.8 by 1.6, and this sin 1 by 8 by 16, which should be multiplied with 1 by 3 divided by 1 by 8. After solution, like 1 by 8, we can deduct from here. And point we just removed. So 13 by 16. Now from here, this is the value comes for the sin theta. And the value of theta is sin inverse 13 by 16. According to this, the correct option, which we have a third option. Next question we have, in an optical fiber, core and cladding were made with materials of a refractive index 1.5 and 1.44 respectively. To observe the total internal deflection, what will be the range of incident angle with the axis of optical fiber? 0 degree to 60 degree, 0 to 48 degree, 0 to 30 degree, 0 to 82 degree. Solution we have launching angle. This is a unique angle for you students. This formula is unique. So note it down. This is important for the JEE examination. Now they may come in the NEET examination, because yet this type of a question not came in the NEET examination. So they may came, and in board that type of a question not coming. So you don't have to prepare for the board this type of a question. Only in the JEE examination, JEE main or JEE advanced, these questions are coming. So mu2 is a given 1.5 and mu1 is a given the value of that 1.414 is actually the value of a root 2. So I'll just did little bit solution and get the value of the sin inverse 1 by 2. So this is the value of 30 degrees. So range between 0 to 30 degrees. The correct answer for this question is option 3. I hope you understand, students. Now moving with the 15th question, a ray of light passes from an equilateral prism such that angle of incidence is equal to the angle of emergence, and each one is equal to 3/4 the angle of a prism. The angle of a deviation is a 45 degree, 39 degree, 20 degree, 30 degree. Let's move with the solution part. Given I is equals to 3/4 times of A, which is equals to 3/4. The value of A is 60 degree, which is equals to 45 degree. I is equals to A plus D by 2. And the value of, if I'm putting the value of I, which comes 45 degree, equals to 60 degree plus D by 2. From here, the value of D we will receive 30 degree. Next question. The distance between the field lens and eye lens in Ramstein eyepiece is 4 cm. Then the distance of the cross wire from the eye lens is 1.5 cm, 1 cm, 5 cm, 5.5 cm. Solution which we have given 2f by 3 is equals to 4. Distance to cross wire from the eye lens 11 by 5 by 12. And the next is given 11 by 12, 16. So little bit solution need here, that will becomes 5.5 centimeter. Next question we have. The two lenses of an achromatic doublet should have equal powers, equal dispersive powers, equal ratio of their power and dispersive power. Sum of the product and their power and dispersive power should be equal to 0. Solution is completely conceptual, that's why I'm just moving with the option. So the sum of the product and dispersive power should be equals to 0. Next question. A achromatic combination of lens produces image in black and white, colored image unaffected by variation of a refractive index with wavelength, color image, highly enlarged image are formed. So solution is completely conceptual. An achromatic combination of a lens produces image unaffected by variation of a refractive index with the wavelength. Next question we have. The refractive index of a material of a plano-concave lens is a 5 by 3. The radius of a curvature is 0.3 meter. The focal length of the lens in air is minus 0.45 meter, minus 0.6 meter, minus 0.75 meter, minus 1 meter. So options we have this, and we just apply the formula 1 by f is equals to minus mu minus 1 by r. From here we can say the option is a 1. What we did, we just put this value over here, like the value of 1 by f is here, mu. So mu is given 5 by 3 minus 1, and the value of radius of a curvature is 0.3. So 1 by 0.3, that comes 10 by 3. Again 1 by f is equals to 2 by 3 and then 10 by 3. So 20 by 3 in the negative, which comes plano-concave. So material of a plano-concave is given 5 by 3, that I did, minus 1 by r, 10 by 3, okay, 2 by 3, and this comes 10 by 3 again, right, 3 3s are 9, okay, that I missed. So minus 20 by 9 this comes. And after a solution, you get the value of 0.45 meter. This is the value of F actually. Okay. So I hope there is no confusion for that, student. Like this is a value of actually 1 by F. So for finding the value of F, you have to do 9 by 20 in the negative, and then you will be get 0.45 centimeter. Last question we have 20th. Match the followings. List 1 we have, list 2 we have burning candle, sodium vapor, Bunsen flame, dark lines of a solar spectrum. Lines of spectrum. So these have options. Now the options is given here. So solution is completely conceptual again. We have fourth option, like the burning candle is the example of a continuous spectrum. Next, sodium vapor is a line spectrum. Bunsen flame is an band spectrum. And the last, dark lines of a solar spectrum is absorption spectrum. So these kind of a question, again, these kind of a question important for the NEET examination, not IIT-JEE examination, but important for the NEET examination as well as for the board examination student. I hope you understand these kind of questions, students. Now, for today's class, I think this will be enough. Okay. Thank you for watching this video, students. And if you have any doubt, you can ask in the chat section. Thank you.